Now that we know how to simplify radicals, now we're going to start solving by undoing. So the first, we're just going to solve this to work to get x alone like we know how to do with algebra. So our first thing we will do is we will add 4, which will give us 3x squared equal to 72. Then we will divide by 3, because remember we're doing order of operations backwards, so the squaring will be done pretty close to last, if not last, and we get x squared equals 24. To undo squaring, we need to square root. And so then we get x equals, remember, plus or minus, because you always get 2 answers. 24 breaks into the square root of 4 times the square root of 6. Square root of 4 is 2, square root of 6 is ugly, so plus or minus 2 times the square root of 6. You're probably going, oh God, are they all going to be that messy? Some of them will come out nice, but not all of them. All right, next example. Now we've got a binomial being squared. Well, remember, parentheses have to be done last, so you can't touch anything in the parentheses till everything else is gone. So we start by adding 21, and we get the quantity x plus 3 squared equal to 121. Well, we can't get at that x plus 3 till the squared is gone, so we will now square root at this point. And then we will be left with x plus 3, because remember, square rooting undoes squaring. Please do not try to FOIL this out, because most of you will end up doing it incorrectly anyways by distributing that squared, which is not acceptable. 121 is plus or minus 11. Well, here's where we go back to similar to when we dealt with absolute value functions. You will have 2 answers, which means we need to fork our problem and separate it out. So now we have x plus 3 can equal 11, or x plus 3 can equal negative 11. And then we solve. Subtract 3 all around. So here we get x equals 8, and here we get x equals negative 14. It would be in your best interest to check these. I'm not checking them just for the purpose of time right now to make sure we get through this, but you should be checking them. Then we go one step further. Now we got a little bit more to work with. We start off, remember, order of operations backwards, so we get rid of all addition and subtraction first. So we subtract 5, and we get 2 times x, the quantity x plus 7 squared equals 20. Then we get rid of all multiplication and division, so we divide by 2, and we get x plus 7 quantity squared equal to plus or, oops, sorry, not plus or minus yet, to 10. Then we square root, and we get x plus 7 is equal to plus or minus the square root of 10. Now, we could split it here, but if you think about it, we aren't going to be able to combine 7 and the square root of 10 because they're not like terms. So in this particular case, we're going to subtract 7 this way, and you get x is equal to, now here's the thing, we're combining these. We always want to put the nice pretty number out first. So we got negative 7, put the plus or minus in between, plus or minus the square root of 10. And as ugly as this looks, that is your answer. So here's the basic premise behind it. If you have x squared, if you get it down to the squared term and it's x that's squared, you're going to get plus or minus whatever that square root is of x, whether it be an integer, whether it be a simplified radical, or in the case of like square root of 10, an unsimplified radical. If you have some x plus minus h squared, you're going to have 2 different numbered answers. Now, if you have an x minus h squared, and it's equal to, I'm going to call it an NPS, a non-perfect square. then it's going to result in something like this. And I just want to kind of give you that idea so you kind of have the idea of what the three types of answer options you're going to have. So then, I want you, make sure there's not another one, sorry. Try these two. We've got 90 equals negative 9 plus the x minus 3 all squared quantity, sorry, had a tongue tie there, and negative 2n squared plus 3 equals negative 21. Solve those, write your summaries, and bring your questions with you to class.